Hello, and welcome to activity number 5 in the variables chapter of Learn to Code 2. This activity is called 3 gems, 4 switches. Our goal here is to collect exactly 3 gems and toggle open 4 switches. So if we look at the puzzle here, it looks like there are more than 3 gems and more than 4 switches. So we may have to keep checking whether we have enough gems and then stop collecting them, and whether we have enough switches and stop collecting switches at some point. So that means we'll probably have to keep track of the number of gems we have at any time and the number of switches that we have at any time. So let's run the puzzle here just to be sure that the gems and switches stay the same each time, and it looks like they do not. There are a large number of possibilities of places where gems and switches can show up, but they appear in random locations every time you run the puzzle. So, okay, the first thing I like to do whenever we start a problem is to ask the question, what do we need to keep track of? So I'll go ahead and put a comment in here and say, what do we need to keep track of? Okay, and in this case, we're going to need to keep track of the number of gems we've collected and the number of switches we have toggled, because we need to stop collecting gems once we get up to 3 gems, and we need to stop toggling switches once we've toggled 4 switches. So let's go ahead and create 2 variables here that represent each of those things. So var number of gems will represent the number of gems that we've collected, and let's set its initial value to 0. We'll initialize it to 0. And also var number of switches will represent the number of switches we've toggled, and again we'll set its initial value or initialize it to the value 0. Okay. One quick comment here, and this is mentioned in the discussion of this activity. These variable names, you should always choose variable names that are long enough to be descriptive for what they're trying to do, but not too long, okay? That it's a hassle to type them out. So in this case, number of gems is descriptive enough to tell me that this is the number of gems that I've collected, and similarly for number of switches. Also, the other thing, when you're giving names to variables like this, we always start our variable names with a lowercase letter. So in this case, it's lower n for number of switches. And we also always use what we call camel case, which means that the first letter of each word, in this case the O for of and the G for gems, the first letter of each word after the first word are capitalized. That helps you sort of separate as you're reading through a variable name. It helps you see the beginning of new words in here. So number of gems and number of switches. Okay. So that's called camel case. The reason is that each one of these uppercase letters in here look like the hump of a camel. Okay, now one of the tricky things about this puzzle looks like it's going to be navigating around it. Okay, it's a long path with lots of turns in it, but there's really only one direction you can go each time there's a turn, so we won't have to make any choices really. The other interesting thing here is it looks like we can keep moving forward until we're blocked, and then when we're blocked we'll have to decide whether we want to turn right or turn left. So I'm going to be blocked right here, and then I'll need to turn right, and then as I move forward I'll be blocked right here, and then I'll need to turn left. And then as I move forward, I'll be blocked again right here, and I need to turn right, and so on. So we could maybe we could maybe just keep walking forward until we're blocked. So I'm going to write these thoughts down as I think of them. Keep walking forward until blocked, and then when blocked, decide which way to turn. Okay, and deciding which way to turn, like we said before, there's really only one choice in each time we need to turn. There's only an opening to the right the first time, then an opening to the left, and then an opening to the right the third time. So really that decision we can do probably in an if statement, and we'll check if we're not blocked to the right, then we can turn to the right. Or if we're not blocked to the left, then we can turn to the left. Okay? So this function, let's go ahead and maybe start writing this function and see if it'll be useful at all. So I'll say decide which way to turn. Okay? Now, we said we know we're going to have to turn whenever we're blocked. Okay, so let's first check for that. If is blocked, then we know we're going to have to turn. Now, if we're blocked, we want to check if we can turn left or if we can turn right. And one way to do that would be maybe in an if statement and say, if we're is blocked to the left, then we know we need to turn the other way. Turn to the right. Because we're blocked to the left, so we can't turn left. That must mean we have to turn right. And similarly down here, I'll say if is blocked to the right, then I know I want to turn to the left. Because we can't turn to the right, we have to turn to the left. Okay? So there's a couple things going on in here, and we've got what's called a nested if statement. We've got an if statement here, and then two if statements nested inside that other if statement. So the only way we're going to ever turn is if we're blocked. That's what this outer if statement says. So if we're blocked to the front, then we want to check, are we also blocked to the left? If we're also blocked to the left, then we must want to turn right. But if we're blocked to the front and we're also blocked to the right, then we want to turn left. Okay, so that's a nice little function. And let's see, since this is all in code now, I can go ahead and delete these comments, except for the keep walking forward, and I'm going to add that right now. So why don't I make a while loop here? I'll say as long as true is true, which is all the time. I want to maybe call my decide which way to turn function, and after I turn, then I should be able to move forward. Okay? Now remember, decide which way to turn first checks to see if we're blocked. If we're not blocked, this does nothing, so then we can just keep moving forward. Okay? So all we're trying to do here is to see if we can navigate to the end of the puzzle by moving forward each time, first checking if we're blocked. If we're blocked, then we either turn right or turn left, depending on whether there's an opening there or not. Okay, let's try this. See what happens. The goal is to we're not going to be collecting gems or switches here or anything. Our goal is to just see if we can navigate get our character to the end of the puzzle. Okay, so he's going to decide which way to turn. Okay, there he goes. He's blocked, and he's also blocked to the left, so he turns right. Here he's blocked, and he's blocked to the right, so he turns left. Here he's blocked forward and blocked to the left, so he turns to the right. Here he's blocked, and then he checks, am I blocked to the left? Yes, so I turn right. This is looking great. He'll be blocked up here again, and he's blocked to the left, so he turns right. Keeps moving forward. He'll be blocked up here and blocked to the left, so he'll turn right. Here he's going to be blocked forward and blocked to the left, so he'll turn right. And up here at the end, he's blocked forward and also blocked to the right, so he'll turn. Okay, he's blocked to the left and right there, which is fine. I don't think we'll ever get to this spot here, so it's okay that he got stuck here, because I'm hoping that we'll stop once we have our 3 gems and our 4 switches, so we don't really need to worry about what's going to happen when he gets to the end of the puzzle, although we could if we wanted to. This condition here would be, by the way, if you wanted to worry about that, he's blocked to the front and blocked to the left and blocked to the right. That would be a good place to end, just to have him stop if ever that condition were the case. Okay, so here's our starting location. He successfully made it all the way through here. Now all we want to do is collect gems and toggle switches along the way. Okay? So maybe a good thing to do here is right after we move forward, let's just call a function that says collect gems and toggle switches. Okay, collect gems and toggle switches. So let's write that function. Function collect gems and toggle switches. All right, now we don't always want to do this. We want to first check and see if we're on a gem. If we're on a gem, then we want to go ahead and collect the gem, right? If we're not on a gem, we can check down here and say if we're on a closed switch. If we're on a closed switch, then we want to toggle the switch. Okay, that's good so far. But now reading these instructions carefully, it says we want to collect exactly 3 gems and toggle open 4 switches. So we don't want to keep collecting gems and toggling switches. Once we have 3 gems, we want to stop collecting gems, and once we have 4 switches, we want to stop toggling switches. And that's where our variables come in here, number of gems and number of switches. Remember that each time we want these, as we move along, we want these variables to represent the number of gems that the character has collected and the number of switches that the character has toggled. So an important point, it's easy to forget this, but right as you collect a gem, the very next thing you should do is go ahead and bump up the value of our number of gems we've collected. Because once we collect a gem, we want our character's variable number of gems to represent that he's collected 1 more. Okay? So number of gems will be assigned to whatever number of gems was before plus 1 more gem. If he gets in here and he's on a gem and he collects that gem, that's where we're going to increment our number of gems variable. And if he gets on a closed switch and he toggles the switch, that's when we want to increment our number of switches variable. So number of switches will now be assigned the value of whatever it was before, number of switches plus 1 more. Okay. Almost there. That's good. In fact, we should run this now. If you think about it, what haven't we done yet? What haven't we done yet? Well, we haven't done the check to see if we have if we have 3 or more gems or 4 or more switches. Right now, he's just going to keep collecting gems and keep collecting switches all the way along on this path if all goes well. So, but good time to try it and make sure that's all working fine. Okay, we've got a gem right here. Collect it. Good. Gonna turn. Okay, good. We'll call this our greedy run, where our character is being greedy and he's just going to keep collecting all the gems. All right, so yeah, notice that he has 5, 6 gems now up in the upper left-hand corner here. He's only supposed to be collecting 3. So he's just going to collect them all up, and we'll let him finish and see if he collects or toggles all the switches as well. Okay, good. He's toggling switches. He's blocked to the front and blocked to the left, so he turns right. Block to the front and block to the left, so he turns right. And even though he finishes here, I don't think we've solved this puzzle. Okay, right. So a little bit of a problem because we haven't stopped because he just keeps on wanting to grab more gems and toggle more switches. So we definitely want this true statement. We don't want to keep going forever and ever and ever here. So a good stopping condition might be, well, we know he'll be toggling switches at that time, so we can say as long as the number of switches is less than 4, we want to keep doing this. As long as the number of switches is less than 4, we want to keep doing this. If we ever have 4 or more switches, we want this while loop to stop, and we want him to just stop where he is, not turning anymore, not moving forward, and not collecting gems and switches, because he's done. There's no reason to keep moving forward or turning or collecting gems once he has his 4 switches, because that happens after the gem. So we could just have him stop then. All right, and the other change we need to make is up here. We collect a gem every time, where we really don't want to be collecting gems once we have 3 or more gems. Okay, so maybe we want to add something in here to our if statement to check. And first we're going to say if we're on a gem, yes, we want to collect gems, but also we want to ask ourselves if, maybe we'll say also our gem counter. Actually, I think what I would like to do maybe is put this in here instead and say like this: if our gem, not gem counter, if number of gems is less than 3, then I want to collect gems and bump up our value. If it's 3 or greater, I don't want to do these things. Okay, so we won't do those 2 things. Okay, that looks great. And here, if I'm on a closed switch, I don't want to always toggle the switches. I also want to check if my number of switches I've toggled is less than 4, then I need to keep toggling another switch and bumping up the value of number of switches. Okay. Okay, so that's added some of these details in here to our collect gems and toggle switches. Now, I don't think, if all goes well, that the character will collect more than 3 gems. Once he has 3 gems, he'll check if he's on a gem. If he is, he'll check and only collect the gem if the number of gems is less than 3. And when he gets on a closed switch, he'll check first to see if his number of switches that he's toggled already is less than 4, and then he'll toggle switches. Otherwise, he's going to skip over this part. All right, let's try this out now. Okay, he's moving forward. He's going to collect his first gem. Turn to the right. Collect his second gem. Collect his third. Let's see. Hopefully he will skip right over these next gems now. Good. Okay, turn to the right. and turn to the right. Okay, going to take the blue portal over, move forward, toggle a switch. You should toggle 4 of them. Turn to the left. Sorry, turn to the right. Toggle the 4th switch, and oh, he stopped. Good. And he stopped because in our while loop here, we said keep turning, moving forward, and collecting gems as long as your number of switches is less than 4. And once it got equal to 4, that was no longer true, so we fell out of this while loop and got to the end of our code and we're done. Okay? Okay, nice, very nice program here. We did a couple of things, three interesting things here. We first asked ourselves, what do we need to keep track of? And we needed to keep track of 2 things here, the number of gems we collected and the number of switches. And we made 2 very descriptive variables with names that use camel case, where the second and third words in each of these variables were capitalized, made uppercase. Then we wrote a nice function that helped us out a lot, which said whenever we're blocked in this puzzle, since it's this path that meanders around the space, whenever we're blocked, we checked if we can turn to the left. If we can't, then we turn to the right. And if we can't turn to the right, then we turn to the left. Okay, so that made working our way around this snake-like puzzle quite a bit easier. And then we also wrote a nice function that collected gems and toggled switches only under very specific conditions. If we're on a gem, first we check to see if the number of gems we collected were 3 or less. And if it was, then we collected our gem and incremented our number of gems. And similarly, if we were on a closed switch, first we checked to see if we had already collected 4 or more. If not, then we went ahead and toggled the switch and incremented our number of switches. And those 2 functions working together let us write this very nice, short, readable main program here that said, as long as we haven't gotten 4 switches yet, we want to check if we need to turn, and turn if we do, then just keep moving forward along the path, collecting gems and toggling switches. And that's it. Okay? All right, nice program here, good puzzle. This is a good one that if you got stuck on this or you're not happy with your solution, this is a great one to put it away for a couple of days, come back to it, and see if you can write it with 2 or 3 nice functions like we did here, and a nice short main program like this. Okay? All right, good luck everybody with that, and good work. We'll see you next time.